Hi everybody, thank you for joining us on our first of the Green Talks. We are joined by colleagues from Aston Group who have put together a talk about green jobs in unusual places. These guys are very special to me in particular because they are the people that look after this building and repair all the leaks and do all our checks to make sure that we have gas boilers at work and all the rest of it. So personally, I'm very grateful that they exist, but they've got lots of interesting things to tell you about in terms of green jobs. I'll hand over to them.
Thank you very much. Hello everybody. Thank you for coming to the Turbine Hall. We're going to talk about a specific job that we've just finished called Greenleaf Road, and talk about the types of roles that were involved in the project. So this is green jobs in unusual places. Do you want to just move it on? Thank you. So Dominic, we have over here, the construction manager, Matt Hayden, mechanical engineer, Scott, the electrical contracts, and I'm strategic communications. So I wasn't involved in the project itself, but the aftermath of it and promoting it and bringing all the data and results together. So if you just want to click on, thank you. We are Aston Group. We are a building services and facilities management organisation. We're based in East London. We have about 140 employees. We deal with a lot of subcontractors. We work commercially and for residents. So we work for universities and hospitals, residential properties, sheltered accommodation, the whole works really. Dominic, thank you. So building services, facilities management and construction. So within these categories, we deal with heating and water. So this environment here, ventilation, drainage, electrical, renewables. Then we have our facilities management. So that's the fire safety, security, alarms, emergency lighting, and all these subjects here. And then the last one is construction. So we have an amazing construction team, and they do all of our construction work, but they're supported by our mechanical and electrical department. So why have we chosen this project? Well, it's a very unique opportunity for Aston Group and Waltham Forest. We got, given the property to sort of showcase all the technology that we could within a certain sort of budget and arena, I suppose, to show how much sustainable and energy efficient technology we can put into it to try and change that building's EPC value. So it was a retrofit pilot, and Waltham Forest are leading the retrofit they are one of the leading councils for retrofit, along with Enfield, I think it was. So we were really flattered to be part of it. We were really excited. We wanted to showcase all the things we could offer. So what the idea was is to demonstrate sustainable measures and innovations. So a lot of the team went out to conferences and shows to try and draw the types of technologies we wanted to showcase within the property into this one project. So they came away with loads of great things, and they can talk to you about that later. One of the parts of the brief was to gain some insight and results from this project. There's no point in doing the project and then saying, look what we did, it's amazing, and moving on to the next. We wanted to gain some insight, some analysis. So we did a lot of analysis before and after, and you can see the results later on. This was a fantastic opportunity to add these sustainable solutions in, but the most important part was that we didn't just do it and see how fancy and luxurious this was to do. We wanted to make sure that residents within the borough could replicate it, and we've learned a lot from doing it. Not everything can be replicated, but a large proportion of it can do in certain aspects. So we've sort of delivered on that part of the brief. It's very interesting, actually, what we can take away from it. And this is sort of why we're here today. We wanted to showcase the large number of people involved in the project. It wasn't your traditional builders, mechanics and plumbers. We had such an array of people that were so excited to be a part of it because it was really showcasing it really brought to the fore what you can do in this type of environment, what roles you can take in this environment. Sorry. So you can see here, there's an array. I mean, this is just some of the jobs. I mean, my role is here, communications officer. Now, you probably think, how on earth am I involved in all this? Like I said, I was part of the latter stages of it. The team the team here was built it, and I helped to gather data, design a white paper with a copywriter, design a film. So that's where my role fits into all this. So if you want to move on. I don't know if anyone knows what the term retrofit means, but there's a short description here. A whole house retrofit is the process of reducing older buildings' emissions by introducing new materials and modern fuel-efficient technologies which help manage energy usage. So what was unique about this property? It was a Victorian property. It's not a new property, and there are many challenges with an older building. We're in one. And understanding the challenges in order to retrofit that building to become the best it can be was a real challenge. Obviously, we needed to bring down the carbon emissions. That was one of the biggest parts of the brief, but also move it from an EPC, so Energy Performance Certificate, EPC E, to an EPC A, which was a huge undertaking, but you'll see later how we achieved it. So if you want to move on to the next one. So this is the energy performance indicator. This house started at E, and our challenge was to move it to an A, which is the best it can be. And this is the very brief, but Aston Group and London Borough of Waltham Forest set the challenge of raising the property's EPC rating from a band E to a band A, while reducing its carbon usage by approximately 50 tonnes of CO2 over 30 years, reducing the annual heat demand from 17,000 to just under 8,000 kilowatts per hour. So if we look at the next one, I think it's a short film, and it will explain a little bit of an overview of the project, and after that you'll have a better view of what we talk about after that. So just enjoy.
In 2019, the UK Parliament declared an environment and climate emergency, setting a target to bring the UK's greenhouse gas emissions to net zero by 2050. We all have a responsibility to be part of the change. Working together, we can help reduce carbon emissions. Currently, housing is responsible for around 20% of our greenhouse gas emissions. Therefore, it's key to identify ways to reduce this as we journey toward net zero. Part of the solution are energy-efficient new build properties. But we can't replace all our current housing with new builds, so we need to reduce carbon emissions in our existing homes. Retrofitting properties can reduce emissions from older buildings by introducing new thermally efficient materials and modern fuel-efficient technologies. Householders can gain a greater control of their homes, reducing energy loss, as well as making them more comfortable, healthy and affordable. Aston Group, alongside the London Borough of Waltham Forest, have been developing the first retrofit property in the borough. It's a 4-bedroom, end-of-terrace Victorian property, and it had an EPC rating of E before we started work. Clearly, its energy inefficiency reflected its age. The challenge we set ourselves was to improve the EPC rating to a band A, while reducing the property's carbon usage by approximately 50 tonnes of CO2 over 30 years. Our first step was to survey the building. We carried out a number of efficiency tests, including air pressure and thermal imaging. This helped us identify exactly where the house was wasting energy and losing heat. Utilising a fabric-first approach, we looked at the core issues identified by our testing, using the data to begin resolving structural heat loss problems. We fitted a new, modern front door, ensuring a better fit and thermal performance. We installed smart ventilation bricks in the walls of the property. These bricks use algorithms that work alongside real-time weather information and air quality data to allow them to automatically adjust, maintaining a better living environment. We insulated the external walls, fixing a layer of rock wool, then covering it with a special render. It was essential to preserve the Victorian brick facade, so instead of using external insulation on the front of the property, we applied it internally. To reduce heat loss through the roof, we increased the thickness of the insulation in the loft of the property, ensuring it was in line with current building regulations. We applied underfloor insulation to suspended flooring. Using an innovative robot called QBot, we were able to do this without needing to remove all the floorboards. We upgraded all windows in the property to low E-coated glass. This provides triple glaze performance in a double glazed solution. Once these steps were complete, we were ready to move on to installing the energy-efficient technology that heats and powers the house. We chose an air source heat pump as the preferred source of heat and hot water. It's more energy efficient than a standard gas boiler, extracting heat from the outside air to provide hot water for the home. It uses electricity to run and can extract heat from air temperatures as low as -15 degrees. We installed a mains pressure storage cylinder. The heating is delivered through radiators designed to work with the low operating temperatures of the heat pump. We fitted a mechanical ventilation heat recovery unit. This takes stale air from wet rooms, such as bathrooms and kitchens, and uses this to heat cool, fresh air as it's fed into the property. We fitted solar panels to the roof, along with a battery storage system, allowing any excess energy created by the panels to be stored and used at a later date. Further excess energy that can't be stored feeds into the national grid. We installed smart power sockets. They allow better management of energy demands, scheduling usage and controlling appliances remotely. Smart LED bulbs were installed throughout the house. They help reduce usage by enabling remote access and allowing lighting to be automated. A shower heat recovery system was installed. This uses residual heat from waste shower water to preheat the incoming cold water. Outside, we created an eco-friendly garden, introducing flowers and plants to help attract and sustain a healthy habitat for local wildlife. All of these changes come together to deliver a sustainable, modern and energy-efficient home. They showcase just some of the ways retrofitting a property can improve the environmental impact of our housing. The work undertaken on the property has successfully changed its EPC rating. Before the house was a Band E, it's now a Band A, substantially reducing the property's energy use and carbon emissions. Whole house retrofitting will play a huge role in how we deliver low carbon homes across the UK. Every single retrofit property we can create will play a role in lowering our household emissions, helping drive us towards our goal of net zero.
So I hope that's given you a good overview of the project. The next part of the presentation is going to be talking about the specifics of who was involved at what stages in this project, and then you can take from it what you will, what interests you, and what as part of the project. So I'm going to hand over to some of the guys to talk about different aspects, and I can jump in when I need to. But over to you, Dominic.
Thank you. I can't believe how well we did, to be honest. It's just good, didn't it? My name's Dominic. I'm the construction manager for Aston Group. We were approached by London Borough of Waltham Forest with a selected property that gives a rough idea of what style of properties they've got in the borough. We was asked to find as many innovative ways that come together to create what we did. But it's no good putting all these aspects in and none of them work with each other. So we appointed a company called Stroma, who did all the heat testing, air testing, which provides all the data, where there's weaknesses, where there's strengths. That data goes to our design team, which is a company called Status Design. They take that information and they put it all together with our help. There's different options come up. So we met with London Borough of Waltham Forest and said, budget-wise, time-wise, what we've got available. These drawings will come across as the design drawings, stroke working drawings. That gets agreed. Then we employ our team to come along and create it. So the objective of the whole thing was to show to landlords, leaseholders, that it can be achieved. So if you've got one of these properties in the London Borough of Waltham Forest, you don't have to do everything, but what we did was demonstrate how much you can do to create an A. And to get an A in a retrofit property is quite an achievement. So the idea is behind all this technology, you've got to get the fabric in position first. So loft insulation, We all know about loft insulation. We've had it for years. That has to be thickened to get a better U value. We've introduced a rock wall insulation system that gets fixed on the outside. The London Borough of Forest have gone for rock wall because of the fire issues with other products. So this goes on. That's the EWI, external wall insulation. That gets a render coat on, and it enhances the look of the property. But as the video said, I can't explain it better than the video, to be honest, but the outlook of the building, you can see it's a Victorian building, and it would be horrific to cover that up. So we've gone with the internal insulation. So you've still got, the building's still got its character, but now it's a modern version of it that we wanted to achieve. We used the Cubot, which sounded to me as a great fantasy idea at start, until we saw it working. In this video, we've got videos of the actual property. It does work, and it is very good. You can still have your resident or yourselves watching your TV, and this gentleman comes in, does it in through 2 or 3 holes in the floor. Then the carpet gets put back. We haven't got to move your TV, we haven't got to move your settee. It all gets done. And that's one of the hardest jobs to do, floor insulation, because it is so disruptive. The floor, carpet, etc., etc. So if you've got somebody living in the property, it's virtually impossible to do. Now this guy comes along, it's resolved it. So an innovative idea that we've created. But this insulation needs the help for the air bricks to keep the humidity right, which Matt can talk about later on.
Q. All on air bricks. So, I mean, air bricks within the property, obviously, normally on timber floors you have airflow going under, but when you're heating a property you actually lose a lot of heat through the floor. So, as well as putting insulation in, there's still a cavity under there that needs to breathe so you don't have moisture and damp issues later on. So what we've done is we've installed the air bricks. They do have smart algorithms that can detect weather outside, the temperature under the floor, humidity under the floor, and only open when they need to allow it to breathe, and then they can close obviously when they don't need to, therefore creating an extra insulation barrier to the property. Low performance glass.
I'll give you the technical side because I don't know. When we come along, it's such an obvious one, the glass. Now, everyone says, years ago, in the 80s, it was double glazing, and everyone's got double glazing now. We've got it. Now, all of a sudden, everyone's going triple glazing. But no one's got the money to put the whole lot again. So what we did, we researched, we actually installed low-end glass. The technology, don't understand, but this gentleman might do. But it was an easier option, disruption to the resident, time, cost, and money. So what we did, we used the existing UPVC frames and just replaced the units, which gives you an equivalent of a triple glazed unit. Yes. So it is a no-brainer, and it's a very easy one. I think this property was about £3,500 just to change the glazing, but it's a big property. But to change all the windows to a triple glazing, you're probably looking at double. So it was an innovative, and we recycled the frames. Yeah,
so from a sustainability point of view, we've been able to recycle the frames instead of throwing them away, sending them to either landfill or to be recycled. So we've saved that process by putting in this new glass, which just by changing the gases that are inside the frames and also the film coatings that go on there, we end up with the triple glazed performance of those windows. So yeah, there's a sustainability point of view that obviously makes it better. Scott, for solar.
Okay, so we installed 12 monocrystalline black panels. Each one of them is 325 watts. Instead of your standard typical blue polycrystalline panels, which you see on most installations, we've gone for a bit more of an aesthetically pleasing panel, which is the all black. We find that it typically looks a lot better. Along with these panels, we've also installed a 9 kilowatt battery. Now, the good thing about that is the standard installation has will generate electricity throughout the day, and then obviously at the end of the day, when the sun goes down, they'll lose all that electricity. But with this, you'll continue to use that electricity through the night when you get back home. Obviously, as we look more towards the future with electric car charging points, when people go away to work and they come back, they'll be looking to charge their cars overnight. In a standard installation without a battery, they wouldn't be able to use this benefit. As you can see on here, we've also referenced that this is enough to charge a Nissan Leaf 100 times a year. Next. See?
That's all heat pumps. Okay, so what we've done is we've looked at ways of getting away from gas boilers, so reducing our CO2 emissions even further. With a heat pump, like the film said, it uses outside air temperature, takes excess heat from the air down to temperatures, I mean the film said minus 15, that unit at push would go down to minus 20 as well. Takes latent heat out of the air, extracts that and puts that into your heating system. So you're achieving, with a gas boiler generally you're achieving temperatures of 75 degrees that flow through your radiator system. This does do lower temperatures, about 45 degrees, but you have it more as like a constant heat throughout the house instead of turning on your heating and getting that instant burst, which to be fair uses more energy. This does it in a slower way, so actually keeping a property maintained at say 21 degrees, you're using less energy because it's having to work not as hard as doing a burst. And also with your hot water, it will go up to 55 degrees. So a lot of the background to these is people say, oh, how am I going to get my hot water? How am I going to get my heating? But hot water wise, you're getting exactly the same temperature, just at a more efficient.
Could you, for the non-technical people themselves, explain how you're going to get that foot pump? I think it's easier to explain.
I think if I say the main concept behind the heat pump is a fridge freezer in reverse. So instead of trying to cool your house, it's trying to heat it. So it's cooling the outside air and using that heat inside. In terms of what's inside, trying to get, people say, how do you get the outside air up to 45, 55 degrees? If any of you have ever had to pump up a football, put the pin into the football and pumped it out, when you take it out, that pin's hot. So that is what we're doing. We're injecting that heat through a tiny hole, which is then expanding that temperature range in the simplest of terms. And that's how we do it. Obviously, the harder you have to make that unit work, the less efficient. The easier we make these units work, running them at lower temperatures and for constant periods of time rather than short bursts, they become very energy efficient and we're not polluting the air with CO2. The added benefit, obviously, with the PV panels is, yes, we're going over to electric, but on this property, for instance, we've got PV that is actually running that unit as well. So in terms of bill-wise, I'd say that we've probably reduced the bills by about 80% on this property. Over to you.
So along with the solar, we've also installed some lighting and smart sockets. What we've tried to do is we've looked at what's on the current market and we've tried to use what we felt was the most innovative and most efficient type of lighting and sockets. So with the sockets, we've got, they're all controlled by an app. So you install them, it's fairly straightforward, it's just like a normal standard socket, but you can log on onto your phone, turn them on and off. You can turn each individual socket on and off as well. So that's obviously quite useful. You can also, if you've got young kids, lock the sockets. So from the touch of a button on your phone, if you don't want the kids messing around with any appliance or anything, you can switch them off. So that's really clever. With the lighting, we've gone for Philips Hue. Philips, I feel, is probably the most innovative one out there. You can set timers, you can change colour, you can change the ambience of a room, and it really is as easy as lying in your bed at night and going, oh, I forgot to turn the kitchen light off, and switching it off. You can turn everything off by one click. So it is really, really clever. And we've all been there when we've lied in bed and thought, oh no, I haven't turned the light off and had to get back out.
and the sensors in the rooms as well.
Yeah, so we have occupancy sensors through the hallway, bathroom. So if you walk through there, it will stay on for a predetermined amount of time that you set. So that's quite useful as well. So you don't, when you go through a hallway, you don't have to turn the light on and turn it off when you leave. It does that for you.
MVHR. Okay, so as you can see, we've installed a lot of ductwork in the loft, but the whole idea of this is to recover heat. So we're not dumping heat outside that we've generated in the house, we're recovering it. So bathrooms and kitchens are the worst of rooms where we normally have an extractor fan, and we just extract it all to outside. So that's heat that we're losing. With this way, it's like having an extractor fan in the room. It's a little vent in the ceiling. It draws that air through, takes it into a unit, uses a method of heat transfer, but obviously you don't want those smells and stagnant air going into your living rooms like your bedrooms and living area. So that air goes to outside and it brings fresh air in, but where it's collected that heat, preheats that air and goes into the living rooms, like the living room, bedrooms. So again, what that does is not only recovering the heat, but it reduces the bills, and also, for example, the heat pump, how much it actually has to work, because it's retaining heat from the wet areas. So that heat that we'd normally dump outside, we've recovered that and used it effectively in the property. Okay. And we have another method of heat recovery. So this is off of we put it on a bath, but it's for the shower. So normally when you're having a shower, a lot of that heat that you've used to wash goes down the plug hole, never to be seen again. With this, it recovers that heat. So as it goes through the plug hole, it preheats cold water coming into the shower, meaning that you have to blend less hot water to achieve the desired temperature. Most showers are about 38 degrees. So if you imagine your cold water comes in your property at 9 degrees, by the time it goes through this unit and to the shower, that's up to 22 degrees. So we've only got to get an extra 16 degrees to actually get it to your desired temperature, rather than, off the top of my head, 28 degrees, you know. So
Once that's fitted.
Yeah, there's no electrical supply, there's no maintenance to it. It's a very simple solution, and the statistics on it is for every 5 showers that you have with it, your 6th one is free. So that's sort of the statistics behind it. Ah, the garden.
The garden. I don't know, I've got my microphone. This one's quite close to my heart. So we had a period of time we had to get this garden looking shipshape. We had an open house festival, a London open house festival, which you might know about. But we had that in 2 weeks of having the garden not landscaped. So we were under a lot of pressure. We had limited budget left. So we employed my mother, who is a gardener, and she is part of the National Garden Scheme. She came, we picked lots of sustainable, well, I say carbon-friendly plants, pollinating plants, and we built a bug hotel. We put a water butt in, a compost heap, and we landscaped it as well as we could for the event, and we think it looks fabulous and it's very presentable. So yeah, we worked very hard on that. I was digging a lot of holes on that day. I said I wasn't a part of this project, but that was what I was a part of. So yeah, it was a great day. It was lovely and sunny, and we had a great time doing it. So that was that part of it. I think we're getting to the results now. So, as you saw in the film, we did achieve an A. We were all jumping about when we found out from our EPC results. Like I said, Victorian properties are notoriously difficult to achieve this. So with all the innovations and the measures that we put in, it got us to where we needed it to be, which proves it can be done if you have the budget and the resources. And then we improved the energy use by 82%, CO2 emissions by 81%, and the running cost by 64%, which is, very important when we're talking about social housing in Waltham Forest. And the electricity consumed each year was 3,900, generated is 3,560. So you can see that it's almost making as much as it's consuming. It depends on different times of year. Summertime is obviously better than winter, but it's getting about 60% from the solar panels and storing it, of course. So yeah, I mean, that was the results. I'll see what I've got next. And I think this is how it looks now. It's a fantastic property for whoever moves in. They are going to love this house. As long as they have a little bit of a user's guide into how things work and use it effectively, it's a brilliant property. And lastly, these are some of the jobs that we have in our business. These are some of the roles we have. And as a different group of people here, I don't know what you're all interested in, but that you can see what we have to offer. And you can join us through many different channels, this being one of them. If you move on to the next one, we have apprenticeships, we have work placements, we have job vacancies, coming up, and they're all really interesting, and it's getting very exciting because of the future of where we're going. So we hope that you enjoyed it. I don't think there's much more, is there, Dominic? And there's a lady wandering around called Rachel. You may have met her, but she's the person to contact if any of this interests you, or you want to join us and you want to speak to us. The lady just here at the bottom is around. So if you want to talk to me, I can pass details on. So yeah, any questions? Quite a big subject.
Do you know how much it costs the landlord to retrofit the property?
Well, we have a cost for what the project cost, but we in terms of what the landlord would pay, it will be quite different because we did the whole thing. And if a landlord wanted to do that, it'd be a big undertaking. But I think the project budget for the show home, and bear in mind it was a show home, it's not for every home, was £112,000 with funding. Half of it was funded by Eco funding, and I think it was Salix funding. Yeah.
It seems a big lot of money to see that amount, but what we're trying to achieve is a fabric first. So with all the technology that Matt, maybe not Scott, because that can be done, but if you've got the fabric of the building contained, and that's the first step, which isn't a great amount of money. There are a lot of grants out there. Then things like heat pumps are going to come on later on. Gas is coming up.
I think
very expensive.
Every measure that you do, starting from a fabric first approach, so getting the air pressure, getting the tests done in order to do the fabric of the building, everything will save you money as you go. The more you add, the more you get out of it. And obviously, air source heat pump works in harmony with solar panels and battery storage. So it's knowing where to start and doing it in the right order was what we suggest. What houses, sorry?
Warner houses.
Warner houses.
Yeah, it's typical London Borough. That, what you saw is quite typical, a Warner house. I think that's older than a Warner house, but generally the criteria is with EWI if it's a solid wall construction. A lot of the Warner houses have got a solid wall because they're from that era, and at the end of it they started going into cavity wall. But the EWI is only used if it's a solid wall construction. So like this, it's a thick wall, but it's just a solid wall, so you do get the cold breezing come through.
Well, I'm just thinking, because obviously the Warner houses were made so that, how Victorian houses essentially, they separated into it into two flats up and down. Warner houses were always developed like that, so that they were housing social people of working class that are working in the local area. So if, for instance, somebody upstairs wanted to do it but not downstairs, would that affect the overall, do they both have to get involved for it to work efficiently?
To reduce the EPC, you have to cover the surrounding area with a certain percentage. So with a lot of the properties we've got, we're doing about 50 EWIs in the borough at the moment. And we're getting a bit of resistance from residents, from neighbours who own the property, are a bit concerned that is it going to have an effect on my property. There is a zero effect, but if you imagine, you wouldn't have to do the whole thing. So if you see the flat and the person upstairs said, I want it, they agreed it because they did that piece, that EPC of that particular property would be better, and it would actually improve the below one slightly because they're using less. Does that make sense? It's just the only issue that people have got is It's a thick render that changes it to a render than the brick. Now, brick is, I'm a bricklayer by trade many years ago, but I do like looking at this here. It's a beautiful thing to look at. So people are a bit resilient to have it covered up, which I totally understand. But just because you've got a red brick front house doesn't mean you can't have it. If you get a percentage of your property covered, it will improve your lifestyle with sound, quality, etc., etc., and it will lower the EPC. So the answer to the question is yes. A 2-block flat can have it at the top, but it won't give any issues to anyone else. So we're getting a lot of resistance from it, from residents, but we're trying to educate people. That's what today's all about, really. There's a lot of education. People need to know, but a lot of people don't know until they can physically see it. So it's an education thing.
It's online, maybe, to educate people.
Sorry?
Would this material be online so that people can educate themselves?
Yeah, I mean, the purpose of making the film was solely for that. Because you can walk into the house for the open house festival and you can see the property and say, oh, isn't it lovely? But what you can't see is the things behind the walls, and so that's why the film exists, to educate people, you know, to tell them about what the air source heat pump does, what the EWI does, and the fact you can have internal, not always external. So I think that was why we felt passionate about putting it together for this.
It's on our website, so if you
it is, yeah.
Show somebody.
And Waltham Forest's website as well. Any other questions?
Yeah, I was
going to say thank you.
Thank you. Thank you. Thank you for coming.